Hi everyone, and welcome to the MathStage. In this video, we'll be solving problems using the laws of indices as you see as the topic. In our previous video, we looked at the laws of indices. So in case you missed that, a link will be in the description below. Now, before we get into the video, please remember to like, share, comment, and definitely subscribe to my channel. Now, let's get started. Say for instance, we have 8 plus 2 raised to the 5th power. What would we do here? Well, we know that 2 here would be the base and the 5 would be the power. As such, the 5 is telling us how many times 2 would multiply itself. And this would be what it looks like. So 2 times 2 times 2 times 2 times 2. So we're going to multiply out these 2's and then we're going to add it to the 8. So here we have 8 plus 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 again is 32. And so our answer is 40. 8 plus 32 gives us 40. Say for instance, we had 2 over 5 all in bracket raised to the 2nd power. What would we do here? Well, the first thing, when in bracket, it means that the squared power should be distributed to all items in the bracket. So the squared power applies to the numerator and the denominator. So it's 2 squared over 5 squared. And if we square these, we can get our answer. So 2 squared is 4 and 5 squared is 25. And this is our final answer, 4 over 25. Let's look at another one, pretty similar to this. If we have 11 squared, all in bracket, raised to the 5th power, what would we do here? Well, based on the laws of indices, we know that if A is raised to the m power, all in bracket, and raised to the n power, it simply means A is raised to m times n. And that would apply in this instance. So here it would be 11 raised to 2 times 5. And our final answer would be 11 raised to 10, since 2 times 5 gives us 10. So 11 raised to the 10th power would be our final answer. If we had q to the 8th power being divided by q to the 3rd power, what would we do here? Well, we know that the law of indices that applies to this is if A raised to the m power is divided by A raised to the n power, it means keep the base and we subtract the indices. And that is exactly what we'll do here. But let's write it out so it's easier for everyone to understand. Two, 3, 4, 5, 6, 7, 8 over 1, 2, 3. Now, if we are dividing, which we are, we would cancel anything that is common. So let's go ahead. This q cancels this q cancels this q cancels this q. And we are left with q raised to the 1, 2, 3, 4, 5 raised to the 5th power. if we had gone ahead and done it as q raised to the 8th power being divided by q raised to the 3rd power, what would we get? It would be q raised to 8 minus 3, and that is q raised to the 5th power. So either way, it would be correct. This time, we're looking at multiplication. T raised to the 5th power multiplied by t raised to the 4th power. Which law of indices would we apply here? A raised to the m power times a raised to the n power is equal to a raised to m plus n. Again, let's go ahead and write it all out. So this would be equal to t times t times t times t times t, 1, 2, 3, 4, 5, being multiplied by t times t times t times t. Now, what would our answer be? T times t would be t squared times t cubed times t to the 4th times t to the 5th times t to the 6th times t to the 7th times t to the 8th and times t to the 9th. We have t raised to the 9th power. If we had just done it as t to the 5th times t to the 4th, and we've gone ahead and add the indices, 5 plus 4, we would get t to the 9th power. So either way, it is correct. In this case, we have 7 over 10, all in bracket, raised to the negative 2 power. Now, as before, we know that the negative 2 is distributed to both the numerator and the denominator. Let's go ahead and distribute. So this would be 7 raised to the negative 2 power being divided by 10 raised to the negative 2 power. Now, from the laws of indices, we know that if a is raised to a negative power, it means that it could put 1 over a raised to the positive of that power. And we are going to put these that are raised to the negative power in this form. So it would be equal to 1 over 7 raised to the positive 2 power being divided by 1 over 10 raised to the positive 2 power. Here we realize that we are dividing fractions. 1 over 7 squared being divided by 1 over 10 squared. So we'll use the rules of division for fraction. And the first thing that we're going to do is invert the second fraction and change the division sign to multiplication. And what is our answer now? Let's multiply since there are no common factors to cancel. We have 10 squared over 7 squared. Now, if you're asked to leave your answer in index form, you leave your answer as this. If not, you would go ahead and square them. So 10 squared is 100 and 7 squared is 49. And that would be your final answer. Let's move on to the next problem. Okay, so the instruction here is to leave in index form. So before we do anything, we want to understand that we have to convert this to index form. Based on the laws of indices, we know that when a is raised to m over n, it is also equal to n being the root of a raised to m. As such, since these two are similar, we know that this can be written in the form of a fractional power. How to do that? Well, since we don't see 9 being raised to a power here, we know that it is raised to the power of 1. Okay, and as n is the root, n is the denominator. So as 4 is the root, 4 would be the denominator. And as m is the power, m would be the numerator. So as 1 is the power, 1 would be the numerator. So let's rewrite this in this form. So now we have 9 to the power of negative 2 being multiplied by 9 to the power of a quarter. What to do next? The laws of indices also tells us that a raised to the m power times a raised to the n power is equal to a raised to m plus n. And here, since the bases are both 9, we would keep the base of 9 just as we kept the base of a, and we would add the powers of negative 2 and a quarter. So let's do that. Negative 2, which would be over 1, plus 1 over 4. Common denominator is 4. 1 into 4 goes 4 times. 4 times negative 2 is negative 8, plus 4 into 4 goes 1 times. 1 times 1 is 1. Our answer here is negative 8 plus 1 is negative 7 over 4. And as such, our answer here is 9 raised to the power of negative 7 over 4. And this is our final answer. What do we do here? Well, the laws of indices tell us that a raised to the m power raised to the n power is equal to, that is right, a raised to m times n. Now, we already know that this negative 3 over 4 is going to be distributed to both the y and the z. So let's do that. Since we've distributed, we're going to go ahead and multiply the indices to get our new answer. We're going to multiply them over on the side. So let's start with the y powers. So y is raised to 4, and it's being multiplied by negative 3 over 4. The 4 would be over 1. Now, is there anything for us to cancel? Yes. 4 goes into 4 once, 4 into 4 once. Anything else? No. Our answer is negative 3. 1 times negative 3 is negative 3, and 1 times 1 is 1. Negative 3 divided by 1 is negative 3. Let's work out now for the powers of z. So we have 3 being multiplied by negative 3 over 4. Anything to cancel? No. So let's multiply. 3 times negative 3 is negative 9, and 1 times 4 is 4. So the new power is negative 9 over 4. Let's write those in. So now we have y raised to the negative 3 power being multiplied by z raised to negative 9 over 4, which gives us the answer to be y raised to negative 3, z raised to negative 9 over 4. And that is our final answer. In this example, we have s to the 4th power over the cube root of 8 times s. Now, looking at this, we know that the cube root belongs to both 8 and s. Let's go ahead and separate the two. So here we'll now have s raised to the 4th power being divided by the cube root of 8 multiplied by the cube root of s. What to do here? Our answer should be in index form, so we're going to go ahead and find the actual value for the cube root of 8 and rewrite the cube root of s in index form. So the cube root of 8 is 2, and the cube root of s in index form is s raised to the 1/3 power. Remember, the root is the denominator and the power that the s would be raised to, which is 1, is the numerator. Now, what do we do here? Is there anything that we could cancel? Yes, there is. Let's write it a little bit more plain so that everyone can see it. So we know that s to the 4th power is being divided by s raised to the 3rd power. From the laws of indices, if a raised to the m power is being divided by a raised to the n power, you keep the base, which is a, and you subtract the indices. That's exactly what we're going to do here. So it would be 4 minus 1/3. So we have 4 minus 1/3. Common denominator would be 3. 1 into 3 goes 3 times. 3 times 4 is 12. 3 into 3 goes 1 times. 1 times 1 is 1. We are left with 11/3. So the new power is s raised to the 11/3 power. So let's write that. And our final answer would be s raised to the 11/3 power divided by 2. Let's look at another example. Here we have 27 raised to 2/3 power. Now, the laws of indices tells us that a raised to the m/n power is equal to a raised to power over root, which would be equal to nth root of a raised to m, or it can also be written in this form. So we're going to work 27 to the 2/3 in both forms. Let's go. So the first, we have the cube root of 27 squared. The cube root 27 squared is 729, and the cube root of 729 is 9. Now let's see if we get the same answer. If we have the cube root of 27, then we square our answer. So the cube root of 27 is 3, and 3 squared is 9. Final answer. So either way we work it, it's the same thing. We just have a couple more left, so don't go anywhere. If we had 2 raised to the 4th power multiplied by 5 raised to the -3rd power, what would we do? From the laws of indices, a raised to the negative power is equal to 1/a raised to the positive of that power. So let's rewrite 5 raised to the -3rd power in this form. So we are left with 2 to the 4th times 1 over 5 raised to the third power. Our answer should be left in index form, so let's work to get our answer. When I put this over 1, it is the exact same thing as 2 to the 4th. It's just easier to put it in a fraction so that everybody can see how we're multiplying. So 2 to the 4th times 1 is 2 to the 4th. And 1 times 5 to the third power is 5 to the third power. And that is our final answer. Here we have z raised to the 8th power times z raised to the 4th power, all in bracket, raised to the negative 2 power. What to do first? Laws of indices, a raised to m, all in bracket, raised to n is equal to a raised to m times n. We're going to apply this here. We're going to work this first. So now we have z raised to the 8th power times z raised to 4 times negative 2, which is equal to z to the 8th power times z raised to the negative 8 power. Now, again from the laws of indices, a to the m power times a to the n power is equal to a raised to m plus n. So we're going to keep the base here and add the indices. So it's z raised to positive 8 plus negative 8, which is equal to z raised to 0. And we know that any number raised to the power of 0 is equal to 1. And that is our final answer. Just 2 more to go. This one is very simple. 5 raised to the 0 power is equal to 1. And now for a final example. If we had 7 raised to the power of y times 7 raised to the power of 3 equal to 7 raised to the power of 4 times 7 raised to the power of 5. What would we do to find y? Well, we already know that in this case, we would be keeping the bases and adding the indices as the laws of indices says. This is equal to this, then whatever we get here, when we add our power, should be the same thing over here. Let's begin. So 7 raised to 4 plus 5 is equal to 7 raised to the power of 9. All right? Therefore, 7 raised to y times 7 raised to 3 is equal to 7 raised to the power of 9. Since they're all equal, that means the indices over here should add up to give 9. So let's work that out. So y plus 3 equals 9. Y equals 9 minus 3. Y equals 6. So let's ensure that when we have 6 here, we get 7 raised to the 9th power. Let's go. So the 6th power times 7 raised to the 3rd power is equal to 7 raised to the 4th power times 7 raised to the 5th power. So I'll keep our base, which is 7, and 6 plus 3 is 9, equal to, keep our base over here, which is 7, and 4 plus 5 is 9. And that is our final answer. Y is equal to 6. Thank you guys so much for watching this video to the end. Please ensure to subscribe and share with a friend, and definitely be back for more videos. Bye for now.